Hello everyone. In this tutorial, I would like to talk to you about linear search, which is a part of array data structure. But we won't be creating our own data structure, array data structure. Instead, we will use built-in array functionality of C++. Below, I will draw an array of size 10. Let's call this array as A. And the array index will start from 0 to 10. Let's write the size as 10. Also, we can refer to size as length as well. In this array, we want to search an element, and this element will be called as key. So in our example, our key value will be 5. What we are going to do is to search our key element 5 in our array, and this will be done by checking every element one by one in this array. At first, our first index, which is 0, contains a value 8. We will check our key value with 8. Are they equal? No. So continue to next index. The next index contains 9. Is 9 equals to 5? No, they are not equal. Then continue. By using this approach, we find our key value at index 7. After we found our key value in the array, we will just simply return the index value, and we will call this search as successful search. If we can't find the key value in the array, we will call it an unsuccessful search. And as you can see, in order to say a search as unsuccessful, we must search the entire array from beginning to end. So let's write our code then. Below, I will use for loop in order to check our key value with the array values. Above, the codes simply check every element in the array by using index operator. Assume that in the beginning the I will be 0 and A of I is 8, which is not equal to our key element 5. If not, we just simply continue in our loop. But if we found the key, then we will just return the index by using return I. If we don't return any value inside for loop, it means that we couldn't find the key in the array. So returning -1 after the for loop will just tell the user that key not found. Now let's look at the time complexity of code. Assume that we couldn't find the key in the array. What must be done in order to say that key is not in the array? We have to search the array. It means that we have to search entire array. If we have 10 elements in this array, we have to check 10 elements in total. But if we have n elements, then we need to search n elements in the array. So our worst case, which is searching through the entire array, will be order of n. But our best case will be order 1, which is constant time. If we find the key element at the beginning, it will be constant, no matter how many elements in the array. So now let's speak average case. For the first element in the array, we need to make 1 comparison, and 2 comparison for the second element, and 3 comparison for the third element. And this goes on like this. And the formula can be written as below. This equation result can be written as n multiplied with n plus 1 divided by 2. This number is the sum of all numbers in our equation, but we want to find the average. So in order to do this, we have to divide the result to n, which is the number of elements in the array. And we can say that average case can be written as order n. Now let's improve our linear search algorithm efficiency. Assume that we find our key element 5 at index 7. which means that we have to make 8 comparison, 1 comparison, 2 comparison, 3 comparison, 4, 5, 6, 7, and 8. In order to reduce the comparison amount, we can swap the key element in the array with the previous element. By this method, we make 7 comparison in our second search. I change the array like this, and as you can see, our key element is now in the index 6. And in order to find the 5 in the second search, we have to make 7 comparison. 1, 2, 3, 4, 5, 6, and 7. By using this approach, we can reduce the comparison in every search. First search, we made 8 comparison. As you can see, in the second search, we are making 7 comparison in order to find the key element 5. If you start counting from the index 0, you will reach to the 7 comparison. First comparison, second, third, fourth, fifth, sixth, and the 7th search. And the 7th comparison, we are finding our key element 5 in the array. And in the third search, we will make 6 comparison. 5 will come here, 5 will come here, and 3 will come here. The code that I am going to write will help us to reduce comparison amount. And this approach is called transposition method. If this line runs, then we will just simply swap a of I with a of I minus 1, which is the previous index. Then we will return index I. The second method is to just bring the key element in the array to the first index. By using this method in our second search, we will find the value 5 by making only one comparison. And this method is called as moveToFront. We are just taking the 5 and swapping with the first index, which is 8. And 5 comes to front and 8 comes to the previous position of 5, which is index 7. The code that I am going to write will help us to reduce comparison amount. If this line runs, we will just swap our key element with the first index and return index I. By using first method, transposition, we are slowly reducing the comparison amount one by one. But in the second example, we are instantly reducing the search time. And now let's write our functions and test them in IDE. I will use Xcode for demonstration. You can use any IDE you want. They will all work fine. At first, I am going to add IOStream library. Then I want to use namespace std. At first, I will write our swap function, which will take 2 parameters and their type will be pointer x and pointer y. I will declare an integer named temp, and temp will be assigned as the value of x. Then the x will take the value of y, and at last y will take the value of temp, which contains the value of x. Then I want to write the linear search. The first linear search algorithm that I showed you, we are checking every element one by one. We are not using transposition and we are not using moveToFront method. And the time complexity of this algorithm is order n. I will name this function as linear search, and it will take pointer a, the key value, and the length of the array. First, create integer I. I will start from 0 it will be less than the length of our array I++. If key equals to a of I, just return the index I. If we can't find the key value in the array, we will just return -1, and I will change this void as int. Let's write our main function, and I will create an array. Its size will be 10, and the first element will be 8, 4, 7, 9, 12, 5, 3, 6, 14, and 21. And I will call linear search. And the first parameter will be the name of our array. The key will be 5 and the length will be 10. And this function will return an integer. And I will call this integer as index. And if index equals to -1, which means that we couldn't find the key in our array, just we will print not found, end line, else cout key value found at position at index, end line, and return 0. Okay, let's run our program and test our linear function. Yes, the key value found at position at 5. 0, 1, 2, 3, 4, 5. It's correct. Let's make an unsuccessful search. I want to search, for example, 35. And 35, as you can see, is not in the array, so it will just return -1 and we will print not found. It's correct. So let's write our transposition method. The parameters will be the same, int key and int length. The same for loop, I++. If the key value equals to a of I, we will not return the index, we will swap the positions. We will swap a of I with the previous position, I -1. Then return I. In case of unsuccessful search, it will just return -1. So let's check our new solution. I will just comment this line, index transposition method key value will be 5 and the length will be 10. Sorry, this will be numbers. Yes, the key value found at position at 5. It is running correctly. Let's write our moveToFront solution. I will just copy this function and paste in here, and I will change the name as moveToFront, and we will just swap the value with the first index, and the rest is the same. Comment this line, int index moveToFront numbers key will be 5 and the length will be 10. Run. Yes, the key value found at position at 5. Let's search 14, and the 14 is located at 0, 1, 2, 3, 4, 5, 6, 7, 8. It is located at the index 8. Let's run the program. Yes, the key value found at position at 8. It's correct. So let's search 40. 40 is not in the list, so it will just return not found. So this is the end of our tutorial. I hope you like it. In the next lesson, I will just try to teach binary search.